Question 2. Sorting algorithm question asking you to use shuttle sort, and you can see here we're actually working in alphabetical order, so it's a letter ordering question, and it wants you to show the list at the end of each pass. So if we start off by rewriting the list, but I'm just going to use the first letters. None of them are the same, so that's fine for our alphabetical order. With shuttle sort, in the first pass you only compare the first two items. They do swap, so there's the end of the first pass. So end of pass 1. In that pass we had one comparison and there is a swap. You can see that they've swapped there. Second pass, now drag along the next one, the next item, which is the third item. They again do swap, so then you would need to compare with the first item, and they don't swap. So at the end of the second pass here, in that pass we had two comparisons and one swap. For pass 3, we bring the next item into play, and it does swap. So we then compare here, and again it does swap, and then we compare here and it doesn't swap. So that's our list, end of pass 3. There we had 3 comparisons and 2 swaps. Notice that the list is now in order. However, with shuttle sort you always need to use n-1 passes. We have 5 items, so we're going to need the 4th pass. So for the 4th pass we just compare these last 2, and you can see there's no swap. And there we are. So that's the first 3 marks. Part B. A list of 10 numbers is sorted into ascending order using shuttle sort. How many passes are needed? Well, we said earlier, with shuttle sort we always need n-1 passes. So if n is 10, the answer is 9. n-1. Give the maximum number of comparisons needed in the 6th pass. Well, in the first pass you compare once. In the second pass you compare either once or twice, but the maximum is 2. The maximum is 3 for the 3rd pass, so for the 6th pass the maximum will be 6. Given that the list is initially in descending order, find the total number of swaps needed. Well, descending order, if you're sorting into ascending order, is worst case scenario. It means that every comparison will bring about a swap. So we've already discussed, we've got n-1 passes, we've got n items, that's the formula we use. Okay, so it's this formula again, it's cropped up before, n-1 over n divided by 2. So total number of swaps, well n-1 is 9 times n, which is 10, over 2 equals, well that's 90 over 2, 45. There we are. Sorting algorithm question, 7 marks.